Hi everyone, we are EcoView. My name is Han Tao. Our team is devoted to exploring the relationship between sustainability and political leaning in each state of United States. To achieve this goal, we have created a GitHub repository containing all the raw data and the code used in our project. Our project is in code with United States goals. We aim to explore the link between sustainability and political leaning of each state in US. Our hypothesis is quite simple, is that states with more sustainability efforts are more democratic. And the results we get is that in the cross-sections analysis, sustainable policy score is the only steady indicator of political leaning. The higher the sustainable policy score, the bluer the states. And also, we get another conclusions that emissions per capita policy score share has a lag effect on political leaning, which aligns to our process. Basically, our structure of our GitHub repository was split into 4 parts, which is data containing all the raw data and clean data and the master table of our project, and also the figures, which is the visualization result of our project, and also it concludes the iterable Tableau dashboard. And the script part is about our codes. It contains data collection, data visualization, data preprocessing, and data analysis. The final part is our presentations, which is our slides, project write-up, and the video. Divisions and library are at the end of our README file. In our first part, we gonna illustrate our data collections. The first file is established by Violet.
So in this file, I scraped the data using Tabula for each year to get the clean energy jobs variables.
And the second data, the file established by Han Tao, and the file is responsible for scraping the bills belonging to environmental protection from GovernTrack website from all US states between the year 2018 and 2021. And here we use a request and Beautiful Soup package to get the information from the website. The third one is quite similar to the second one, so we just skip it. And we jump to the second sector is our data preprocess. The first file is established by Anming.
We get our raw data from the United States Environmental Protection Agency. This file contains 3 steps. The first step is to calculate group day ratio, which is defined by AQI against the total number of observations. And then I drop unincorporated territory of US, such as Puerto Rico. And then I concatenate the years from 2018 to 2021 into one file.
The second file is established by Violet.
So for this file, I cleaned the data for variables related to clean energy jobs, which are clean energy jobs employment, clean energy jobs growth, and clean energy jobs share. And I dealt with missing value by approximating it using linear regression. I also combined other data sources to calculate the variables. And finally, I exported the data into a CSV file.
And the third one is also established by Violet.
So for this file, I normalize the data for all years and export them into a CSV file.
Political leaning is our dependent variable. Here is the code about how we can produce the political leaning.
One challenge in this data is that we have missing values in political leaning because the geography of political leaning changes every 2 years. So we have missing value in the year 2019 and 2021. The solution is pretty simple, is that we take the mean of the conjunct years. For example, in year 2019, we insert the missing value as the average of the year 2018 and 2020.
The final step is our prune final data. It's also established by Anming.
The first step is to drop redundant columns that we think are not our interest. And second step is to incorporate the state population that we can calculate emission per capita based on the total emissions.
After finishing our data preprocessing, we are going to see about the codes from data visualizations. The first file is established by Violet.
So this file plots and saves the heat map for each year's data and the average data. We use the heat map to explore the correlations between the variables.
The second file is established by Anmi.
All data are organized by US states, so we can plot either feature onto the US map. This includes the environmental factors and political leaning. And also each map is organized by time.
After finishing the data visualizations part, we're gonna go to the final step of our project, which is data analysis. Here we have 3 files. The first file established by Anmi is about how to cluster the state using TSNE method.
Due to the high dimensionality of our environmental protection features, we plan to utilize TSNE dimension reduction to transfer them into a 2-dimensional space for better visualization. Our hypothesis is that if political leaning differentiates states, we should observe blue and red states clustered in separate groups. This script involves 3 nested loops. The primary loop is looped over years, as our data is spanning 4 years, with dimension reduction applied in each year. And the secondary loop is used to search for the optimal hyperparameter perplexity. The third loop here is to repeat the whole process multiple times to account for the algorithm's randomness. Subsequently, we plot the states in 2-dimensional space, with colors representing their political category and hue indicating intensity. Additionally, we add state names as annotation besides the scalar plot. Now let me run the code here. I added some notations during the running. Here you can see that it plots the year it is calculating, the perplexity which is used, and also the process. As it is repeated 60 times, after it reaches the 60 times loops, it will turn to year 2018 with another perplexity score. You can see it's now turned to perplexity at 8 in the year 2018. Because this script runs a long time here, I only give you a glimpse of how the code really runs.
And there's another file which is established by Wallet, which performs the OLS regressions.
So this is the OLS regression file. And in this file, I ran the descriptive statistics of the dataset, the distribution of the variables, the OLS regression model, and I plot the residual plots for variables that are significant. So for demonstration, I'm only going to demonstrate the data with year 2018 because the years are pretty much the same. So now I am running this code, and it first shows the descriptive statistics of all variables for year 2018. And it also gives the distribution of the variables. Let me switch screen here so you can see the distribution plots. So this is the distribution of all variables. And in this OLS regression, the only significant variable is policy score, and it is sort of normally distributed. And our Y variable, the political leaning, we can also say that it is approximately normally distributed. And now let's check the residual, the OLS regression plot. So in here, we have the OLS regression results. And as you can see, the policy score is the only significant variable for 2018. And it also gives the residual plot of policy score. And let me show that plot to you. This is a residual component and component class residual plot of policy score in year 2018.
So our codes are developed by different team members. We don't compile them into a single document. The table below provides a detailed view of each code, and our total rows of the codes of our project is 987. Thanks for your listening.